Hey everybody, it's Bruce and the dog on the floor, and today we are going to be talking about Axon models. Specifically, we are going to be bridging the difference between the linear regression that we just finished and a more robust machine learning model. So what we're talking about is taking that simple linear formula, that mx plus b, where m and b are these parameters that we want to tweak to make a better and better prediction, and x is an input, and then the result of that is some output. So we're going to be building that model, that mx plus b. We're going to be looking at the parameters, that m and the b. We're going to be looking at the input, that's x, and we're actually going to use that to make some predictions. This should be an illuminating presentation if you've been struggling with how the different pieces of the Axon library work together. Let's get started. So I'm here in IEX and I have at my disposal NX. So you can see the functions there. I have Axon and I have the XLA, though I'm not going to use it. Those are the only three dependencies that I've included. But I'm actually not going to use them to start things off. What we're going to do is we're going to build a function called predict, right? So, and this is just a function that takes a model, right? And this model is nothing but a configurable function. And the one that we're going to use is basically going to predict the value of a basic line, right? And the second thing is that this model is going to be a function, right? And then the second thing is going to be params, but we're going to pass those in the form of, remember we had this mx plus b, right? Well, x is going to be the input of this function. M and b are going to be the parameters. And then I have an input. What am I going to do? Well, I'm going to call with the params and the input, right? Okay. All right, so it says that the m and the b are unused. That's correct. Really what I was trying to do is to show you that we had parameters, and I wanted to show you the shape that we passed it in. So neither one of these are used, but we'll actually use them when we build our function, right? So let's build our model function. And that's going to take, looks like it's going to take the parameters and the input, right? And so this is going to take the m and the b, and it's also going to take the x. And what we're going to do is say m times x plus b, right? That's all it is. And so now I can use, if I have a particular m and a b, so for example, if my params, if I have m, so m is maybe 4 and b is 2, then I ought to be able to say predict, and then I could take the model, and then I could take my params, and I should get 4 times x plus 2. So let's say I pass in 2. So 4 times 2 is 8 plus 2 is 10, right? So I'm going to pass in the value of 2, and I'm going to get 10. This is exactly what an Axon model is. It's a model that you can configure with parameters, and this is important because we have this training step so that initially the predictions are bad, but after we do some training, we can shift those knobs and levers so that it makes good predictions, and then we can actually use it either to check our implementation or actually in production to make predictions and do things like recognize images and handwriting and all those things that you need machine learning to do. So let's go ahead and see what this looks like in an Axon model next. Basically, think of Axon models as functions that take tensors, and the tensors have two forms. First, the parameters that we want to be able to tweak to make better predictions, and second, the inputs. And they also produce tensors. And so we might start with a layer that looks like an input layer and then pipe that into a dense layer which does nothing but a linear regression, right? And so that means that particular model would work on a line. So let's put that in context of the function that I already have, this model that does mx plus b. And this is actually the basis for the dense layer. But we're not going to start with a dense layer. We're going to start with an input layer. So this is what that might look like. I'm going to say input model is equal to axon.input. And I'm going to give this the simplest possible shape, just a 1 by 1 grid, if you will, just a matrix, right? So there's a batch. The batch size is always 1. It's always going to take a single input value as part of that batch, right? And so I want to show you a couple of things about that, is that this has one layer. If you had multiple layers, you would see them listed one after another. This has the shape of the layer, and it has the parameters that we're setting. Now, since this is an input layer, there's no function that we're going to run. Like, for example, if we had the input, let's say axon.predict, right? And so what are the three things that I need? Well, I need the function. Well, in this case, the function is the input model. And then I need the parameters, and in Axon, parameters are expressed in a map. And in our case, this map is going to be empty because remember, there aren't any parameters in an input layer, right? And then we can provide the input, but we're going to do it in the shape of a tensor. And what's the shape? This is a 1 by 1. So let's go ahead and pass it like, I don't know, index.tensor 1. And that's closed correctly. Oh, I need to require Axon. So let's fix that. Because this is a macro, right? And all it's saying is that we need Axon to be required, so it's set up the all the preconditions for compiling these macros as we consume them. Macros are just code that writes code. Okay, so we're going to do a prediction, and look, we passed in a one, and we got a 1 back out, right? And you can imagine if this was a 314, that's what we get back out, right? So a input model is just something that takes input and passes it straight on through. And in Axon, what this allows us to do is to take input of a common shape. And so often what we'll do, rather than having a 1 here, just so the batch can have as many elements as we want, we might have something like the input model might have something like a nil 1, right? And so then we can, when we make a prediction, we could say 0.0 and 314. Oh, I got confused on my shape here. So what this would be is 0, 0. Yeah, so I had my dimensions wrong. But in this case, it's going to take these inputs and pass them straight on through. And since Axon doesn't know how big my batches are, I can use this to pass as many observations as I would like. Okay, so we have an input layer. Now, how do we do a multi-layer model, and one where I actually take advantage of the linear model that has that mx plus b, but instead of working with scalars, it works with tensors. We're going to do that next. All right, so the next step is for us to build a model that's a little bit more sophisticated, right? So what we can do is we can say Axon model. So let's build an Axon input layer. Remember, we wanted this to have a shape that had nil first, which means that we're okay with Axon doing a little broadcast work to get us into the right dimension, right? We don't know how big the dimension is in terms of rows, but it has a single column. And then we're going to pass this thing into a linear layer, which in Axon, in most of machine learnings, this is called a dense layer. So Axon. So basically what this is we're effectively solving a system of equations. Well, this one's not going to be very interesting because we effectively are going to use a single equation rather than a system of equations. And this one is going to take the form, as you might have guessed, mx plus b. And look, I have different layers to this thing, right? So I have the input layer, and then I have the dense layer, and each one of these is given a name. And look, this has two parameters, and you can guess what they are. They're going to be an m and a b. The b is for bias, and the m is going to be, I think, well, let's see what it is. Let's get the parameters for this model. So I could say axon dot param, and let's get it for the model. Oh, get the param2 and param3. Oh, no, what I need to do is initialize the model. Yeah, so basically this function is going to initialize, is going to build my first random guess using some of the papers and linear algebra to choose the random numbers in the best way possible. But you can see that this is what's been given as the parameters. So so there's a 0, and then there's a 0, 1, 4, right? And so this is the m. So what we can actually do is make a prediction, but rather than try to kind of grind through these complicated values, let's use some integers in here instead, right? So let's say that or actually we could use some floats, but we'll use floats of kind of known round values, the ones that we had before. For the m, or the k in this case, the kernel, we'll start with a 4, and this will kind of set to 2. So let's say the k, well, let's keep calling it an m. So this is going to be a nx.tensor, right? And remember, this thing is going to take the shape like that, right? So, and we want to mimic this shape right here. So that's exactly what we've done. So we get an F3211. And the B, so what kind of shape does that take on? That takes, well, it's just a single dimension, which you'd expect because this is a constant. We're going to add this to every row or column of the tensor, depending on the system that we're working with. Okay, so this is going to be nx.tensor, and we don't have to go as deep this time. So let's say this is 2.0 like that, right? So now we can build our params to look exactly like they were before. We know what these layers are called. They're called the bias and the kernel. So let's do the kernel first. And this is M. And then let's do the bias next. And that is the B, like that. Okay? So now I ought to be able to say, Axon, I can run a prediction, right? And remember, we want the model. And all this is the configurable function, and we have to plug in the parameters, and then we have to plug in whatever x that we want to guess, right? So our parameters we've already built, and maybe we want to get a guess. Let's see, what kind of shape should the guess have? Maybe it should have a shape like this, right? We want to put that in a tensor, right? Okay, and so we're going to make a prediction, and so what we ought to get is mx plus b, or 2 times 4, which is 8, plus 2 is 10. And so that's what we get. But as you might have noticed, we are not limited to a single batch of numbers, so we could plug in a 3 as well. And you can see that this is going up by 4 every time because that's the slope, just as we expect it to be, right? So what we have here is an Axon model that can come in multiple layers, right? And one of the things that we're often going to do is we'll plug in different what's called activation functions to actually add different computational properties to the models that we build. Like for example, we might want our model to build something that doesn't grow and grow and grow as we make more and more complex predictions, right? So maybe I want a dense layer of 1, and maybe I want to add an activation. And the activation is maybe the tangent. What you're going to see us do in the sections to come is we'll start building these models with pipes. And these pipes are going to actually have functions that we layer in between called activation functions. So what's going to happen is you are going to see models that get increasingly complicated, but they're going to work exactly the same way. We're going to pass in the model, the parameters, and some input data. And so as we get into the next few lessons, look for that. When we build the dense layer, this is exactly what's going on under the hood, except instead of one-dimensional data that you see inside here, we're going to be passing in tensors, and that will allow us to represent more complex concepts. And that's an excellent thing. For Bruce and the dog on the floor, this is Groxio Learning.